One problem that we often have in capital budgeting is evaluating competing projects that have different lives, different investment lives. And it turns out that the simple net present value criteria could be problematic in terms of this type of evaluation. So suppose that there's a machine that we need to have for the production process. And this machine we could obtain from two different vendors. And one vendor, the machine lasts for 5 years, and the other vendor, the machine lasts for 7 years. And we could go through and look at the cost, the initial cost of the two different machines, and we could look at the revenues that the machines will generate, and we can calculate the net present value. And it might turn out that the net present value of the 7-year machine is lower than the net present value of the 5-year machine. Now, the problem with this analysis is that at the end of 5 years, we're going to have to replace the 5-year machine, and at the end of 7 years, we're going to have to replace the 7-year machine. So what we'd like to do is to put them on an equivalent basis in terms of the timing. So it would be nice to have a situation where we could evaluate kind of over a common time horizon. And I guess we could do this if we looked at a sequence of, I guess 35 years would be common. So we have like 7 purchases of the 5-year machine and 5 purchases of the 7-year machine. And there we would have a horizon of exactly 35 years, and it would be common for both. So we could do it that way, and that will actually give us the correct answer. But what we usually do is something a little different, and that's called calculating the annual equivalent cost. So here, what we do is we evaluate the net present value of the machine that lasts for 5 years and the net present value of the machine that lasts 7 years. That's the first step. And actually, we might have already done that step. The next thing that we do is to calculate the annuity factor that has exactly the present value of the machine's net present values. Okay, and the annuity factor would be calculated over the life of the machine. So what we would do for the 5-year machine, it's got some net present value. We would use the annuity formula to calculate the equal cash flows over a 5-year horizon whose present value is exactly the net present value of this particular machine. And we do the same thing for the 7-year horizon machine. So it's got some net present value. Calculate the annuity factor that exactly delivers that net present value. Now we put things on an annual equivalent basis. And what we can do is to look at these so-called, and is referred to as the annual equivalent costs. Look at these two annual equivalent costs to see which one makes the most sense. Now, I've done this on the basis of net present value. It's sometimes done on the basis of present value, and that's perhaps why it's called the annual equivalent costs. But it really doesn't make any difference. The main idea here is to spread out the cash flows that represent the present value, or the net present value of the project. Spread them out equally over the years. In doing this, we can obtain a way to make a decision where you're comparing apples with apples rather than apples with oranges. In this case, the annual equivalent costs allows us to make the best possible decision in terms of evaluating which technology or machine is going to increase the value of our firm the most. This is called annual equivalent cost.